Welcome back. Today we're going to talk more about inverse trig functions, so part 2. Just to remind you where we left off defining our inverse trig functions. Our inverse trig functions are arc sine, arc cosine, and arc tangent, or the inverse sine, inverse cosine, and inverse tangent. And remember, your arc sine, arc cosine, and arc tangent give you an output of an angle. We had to restrict the original graph of sine, cosine, and tangent to make them one-to-one so that they were functions that could have an inverse function. Remember, only one-to-one functions can have an inverse. And so when we take the arc sine and we get out an output angle, that angle has to lie between negative pi over 2 and pi over 2. For the arc cosine, when we get an output of an angle, that angle has to be between 0 and pi. And for the arc tangent, when we get an output angle, that angle has to be between negative pi over 2 and pi over 2. So just to remind you how we restricted our sine graph, so here is y equals the sine of x. We restricted that graph to make it so that it was one-to-one, and we restricted it between negative pi over 2 and pi over 2. And notice our range from negative 1 to 1 is accounted for. And now here's the graph of the inverse sine. Notice the domain is from negative 1 to 1, and my range, my output angles, are from negative pi over 2 all the way up to pi over 2. For the arc cosine, remember we had to restrict our graph going from 1 down to negative 1 to make sure that all those outputs were accounted for, and we restricted the angles from 0 to pi. So here's the graph of the inverse cosine. The domain is negative 1 to 1, and my outputs range from 0 all the way up to pi, so that's my range there. And for the tangent, we just restricted it to one of those little S-shaped curves in between those two vertical asymptotes here. And when we do that inverse, again, we had to restrict this from negative pi over 2 to pi over 2. And the inverse tangent, it goes from negative infinity all the way up to positive infinity. We now have horizontal tangents at pi over 2 and negative pi over 2. And we're restricting our angles anywhere between that negative pi over 2 and that pi over 2. All right, so let's take a look at some examples. Let's find the exact values of the arc sine. If we're looking for the arc sine of 1/2, that means arc sine of 1/2 is equal to an angle. Remember, arc sine gives an angle. What that means is that the sine of that angle is 1/2. Now, there are infinitely many angles where the sine is 1/2, but there's only one angle on the restricted graph of the sine where we get 1/2, and that angle is pi over 6. So the arc sine of 1/2 is pi over 6. That is the one and only angle on the restricted graph on the range of the arc sine where the sine is equal to 1/2. For the arc cosine of negative 1, the arc cosine of negative 1 is going to give you an angle. We'll call it theta. That means that the cosine of that angle is equal to negative 1. Now, as we know, there are infinitely many angles that give us an output of negative 1, but only one of them is on the restricted graph for the arc cosine that has that output. Remember, the output angle for the arc cosine has to be between 0 and pi. So pi is the only angle on that range for the arc cosine where the cosine is equal to negative 1. So the arc cosine of negative 1 is the angle pi. Let's do the arc sine of negative root 2 over 2. So the arc sine of negative root 2 over 2 is going to give us an output of some angle. And again, the arc sine output angles have to be between negative pi over 2 and pi over 2. So there's only going to be one angle where the sine of theta is equal to negative negative 2 over 2, negative root 2 over 2, where that angle is between negative pi over 2 and pi over 2. So the range, remember, of the arc sine is between negative pi over 2 and pi over 2. So the angle has to be between those two angles there. Cannot be outside of that range. So here it is. These are our only choices for angles. And negative root 2 over 2 is probably right about in here. So we need to figure out what that angle is. Well, sine and also tangent are odd functions, which is a really nice characteristic. What that means is that the sine of a negative angle gives you the opposite of the sine of the positive angle. Same thing for tangent. The tangent of a negative angle is the opposite of the tangent of the positive angle. So what does that mean? Well, we know that the sine of pi over 4 is root 2 over 2. So the sine of positive pi over 4 is equal to positive root 2 over 2. Since sine is odd, that would mean that the sine of negative pi over 4 would equal negative root 2 over 2. So that means that the arc sine of negative root 2 over 2, the angle we are looking for is negative pi over 4. And that works for the tangent too. So if we wanted to do the arctan of negative root 3, well, the arctan of negative root 3 is going to give us an angle. We'll call it theta. That means that the tangent of theta is equal to negative root 3. Now remember, our output angle has to be between negative pi over 2 and pi over 2. So because tangent is odd, we can ask ourselves, where is the tangent equal to positive root 3? And that is pi over 3. So where is the tangent equal to negative root 3? That would be negative pi over 3. So the angle we're looking for on the restricted graph is negative pi over 3. So the arctangent of negative root 3 is negative pi over 3. Now that little trick, that odd trick, does work for the arc sine and the arc cosine, or the arctangent, but it does not work for the arc cosine because the arc cosine was restricted from angles between 0 and pi. So if we wanted to find the arc cosine of negative root 3 over 2, well, that's going to give us an angle. We can call it theta. And that means that the cosine of theta is negative root 3 over 2. Now remember, we restricted our graph so that the output angles for the arc cosine have to be between 0 and pi. Well, so that's basically restricts it to quadrant 1 and quadrant 2, right? Halfway around the circle there. And so for the cosine to be negative, well, it can't be in quadrant 1 because all angles, all trig functions are positive in quadrant 1. It must be in quadrant 2 because only the sine is positive in quadrant 2, the cosine would be negative. So the angle we are looking for is some angle in quadrant 2. So it's some angle in quadrant 2, we'll call it theta. Well, bring back our reference angles. Here's our reference angle, theta prime. And so how are theta and theta prime related? Theta plus theta prime is going to give us pi. Well, what do we know? We know the absolute value of the cosine of an angle is the cosine of its reference angle. So what angle is the cosine equal to positive root 3 over 2? Well, that's one of the angles we should know in quadrant 1, which is pi over 6. So we know that the reference angle must be pi over 6. Because again, the absolute value of the cosine of an angle is equal to the cosine of its reference angle. So the absolute value of the cosine of theta, which would be the absolute value of negative root 3 over 2, well, we know the reference angle that gives us the cosine of pi over 6 is root 3 over 2, so this reference angle must be pi over 6. So using that, we can solve for theta to see that theta is the angle 5 pi over 6. So the arc cosine of negative root 3 over 2 is the angle 5 pi over 6. That is the one and only angle between 0 and pi where the cosine is equal to negative root 3 over 2. Okay, so if you recall from our last video that two functions are inverses of one another if when you compose them together, they undo each other completely and you get back that original input. So f composed with f inverse of x would give you the same thing as f inverse composed with f of x, which gives you that original input of x. So that means that the arc sine of the sine of x is x and that the sine of the arc sine of x is x. The arc cosine of the cosine of x is x, and the cosine of the arc cosine of x is x. The arc tangent of the tangent of x is x, and that the tangent of the arc tangent of x is x. However, you have to be very careful because we had to restrict our arc sine, arc cosine, and arc tangent, restrict the range of those angles there. You have to make sure, that you are remaining in the correct domain and range of the functions in the inverse functions when you do this. So for example, if we wanted to do the arc sine of the sine of negative pi over 3, well, the first thing you could do is you could take the sine of negative pi over 3 and then take the arc sine of that angle, or of that value to get out that angle. But because negative pi over 3 is in the restricted domain and range of the arc sine, then you can just say, okay, the arc sine of the sine will cancel and we're left with that negative pi over 3. Seems pretty simple, but what if we mix up our functions? What if I want the tangent of the arc sine of negative 1/2? Well, the first thing we're going to want to do is find the angle. Remember, arc sine, arc cosine, and arc tangent give us an angle. So we'll find that angle, arc sine, of negative 1/2, and once we figure out what that angle is, we'll take the tangent of it. So the arc sine of negative 1/2 is an angle, we'll call it theta. That means that the sine of theta is negative 1/2. Remember, our angle for the arc sine has to be between negative pi over 2 and pi over 2. Well, since we know that the sine of pi over 6 is 1/2, and the sine is odd, that means that the sine of negative pi over 6 would be negative 1/2, so the angle we're looking for is negative pi over 6. So, since we're taking the tangent of this angle right here, and we just found that angle, we're really just looking for the tangent of negative pi over 6. Well, keep in mind again that tangent is odd, so the tangent of positive pi over 6 is square root of 3 over 3, so the tangent of negative pi over 6 would be negative square root of 3 over 3. So let's do another example. Let's find the cosine of the arc sine of the square root of 3 over 2. Remember, arc sine, arc cosine, arc tangent give you an angle. So let's find the angle, the arc sine of root 3 over 2, call it theta. That means that the sine of theta is root 3 over 2. That angle has to be between negative pi over 2 and pi over 2, and the sine of pi over 3 is root 3 over 2. So the angle we are looking for is pi over 3. So here I'm taking the cosine of that angle, which I just found that angle to be pi over 3, so really I'm just trying to find the cosine of pi over 3, which is 1/2. Let's do another example. Let's take the tangent of the arc cosine of negative root 2 over 2. So arc cosine of negative root 2 over 2 is an angle, we'll call it theta. That means that the cosine of the angle is negative root 2 over 2. But remember, we restricted the arc cosine that the output angle has to be between 0 and pi. Well, because the cosine is negative, that means we must be in quadrant 2. So we'll do the same thing we did earlier, where we'll draw some angle in quadrant 2, and here's theta. Here's our theta prime. So we know that theta plus theta prime is equal to pi. Well, because the cosine of the absolute value of the cosine of an angle is the cosine of its reference angle, and we know that the cosine of pi over 4 is root 2 over 2, that must mean that theta prime is root pi over 4. And so from that, we can solve for theta, and we get that theta is 3 pi over 4. So now, because the tangent of the arc cosine of the negative root 2 over 2, we found this angle, so we're going to say that this angle is 3 pi over 4, so we're going to find the tangent of 3 pi over 4, which will be the sine of 3 pi over 4 divided by the cosine of 3 pi over 4, which is going to give me root 2 over 2 divided by negative root 2 over 2, or I get that the tangent of the arc cosine of negative root 2 over 2 is negative 1. Let's do one more example. Let's do the sine of the arc cosine of 2 over 3. We'll set it up similarly, where the arc cosine of 2 over 3 is some angle, we'll call it theta. That means that the cosine of that angle is 2 over 3. The problem here is that there isn't a highlighted angle on the unit circle that the cosine is equal to 2 over 3. So what do? Well, remember that trigonometry is the measurement of triangles, so why don't we draw a right triangle? If the cosine of theta is 2 over 3, and based on our right triangle trigonometry, cosine is adjacent over hypotenuse, then we can label the adjacent leg as 2 and the hypotenuse as 3. Then we can use our Pythagorean theorem, a squared plus b squared equals c squared, to get that a squared plus this leg squared equals the hypotenuse squared, which gives us a squared is equal to 5. So to solve for a, we'll take plus or minus the square root of 5, but since a is a length here, we'll take the positive square root, and we get that this leg is root 5. So remember, this arc cosine of 2/3 is equal to an angle, we called it theta. So that means that the sine of the arc cosine of 2/3 is the sine of that angle theta. Well, we labeled that angle theta right here. So now we can use our right triangle trigonometry to take the sine of that angle theta, which would be opposite over hypotenuse, to get square root of 5 over 3. So the sine of the arc cosine of 2/3 is the square root of 5 over 3. Keep in mind with trigonometry, you can draw triangles and use right triangle trigonometry. That's it for now. See you next time.